Hello everyone, I hope you are doing very well. So today we'll be continuing our series of tutorials on Verlet Integration implementation. This is part 3, Shapes. So in part 1 and part 2 we introduced the theory and a first implementation for simulating single point motion. In this tutorial we'll be handling shapes and for example here a box movement or rectangle movement. So let's pick up where we left last time. So last time we did the movement of a single point or a ball. So let us start by defining a shape structure. So def shape, and it's going to take as an argument a list for points, which is, let's initialize it to let's basically single point list holding one point. It's going to be x10 and y10, and let's set old y and old x to 0, 0, and let's set the radius to 3. Also, it's going to take as an input joints. And joints here is going to be a list of lists. Basically, those lists inside will be the references for the indexes of the positions of every point in the points list. So here it means that the 0th point is connected to the last point. So basically it will return. Let's do return and a dictionary. The keys will be the points and the joints, and the values as well are the points, inputs, and joints. So let's just go ahead and do that here. And next we'll be defining a function for moving the shape. Def move shape of shape. And this function, what it will do is that let's loop through all the points that are held in the shape dictionary. So for p in shape of points, and what we'll do is that we will move p of p, basically. It's the same for the collide function. So def collide p, collide shape, basically of shape, and we'll do the same thing here for p in shape of points, and we'll do collide p of p. So collide p of p, and so yeah. Now we'll need to define a function for rendering and one for simulation. So def render shape of basically shape technically. So, and this time we'll loop through the joints that are in the dictionary, and we'll be displaying a line between every 2 points of the joint. So for j in shape of joint will be for joints, and what we'll do here is so in order to draw the line, we'll need a start position, an end position, a color, and a thickness. So let's start by initializing the color. Let's set it here to a blue color, I guess. So it's gonna be 100, 100, and let's do 200, 200, 200, I guess. Yeah, 200 is enough. So yeah, as I was saying, we need the start position and end position. So let's just write start equals, let's leave it and we'll define it later, and end position. And what we'll do is we'll do pygame dot draw, and we'll call the line function, which takes the display, the color, and also takes the start and end positions. And we'll need the thickness actually. Let's let's put thickness here. Where is thickness? Let's initialize the thickness with, let's say, 3. Alright, so let's define now the start and end positions. So start will be, basically what we'll do is we'll call a shape of points, and we'll technically need here an index. Let's leave it for later. And we'll call chords from the point, and here of 0 to indicate x. So in here the index is going to be j of either j of 0 or j of 1. So for the start position is j of 1, and for the end is going to be j of 1. For the start is j of 0. So the same thing for the y coordinates, is just we will change 0 for 1. So let's copy that and do the same for the end position. This time it's not j, it's j of 0, it's j of 1, sorry. Alright, so I guess that will be it for the render shape function. Next we'll need to define another function that will do the simulation. Def simulate shape, and it takes as an argument, it will take shape dictionary and basically the w and h for width and height. Let's initialize them to 500 each. Alright, so basically here it's going to be the same process that we did for the simulate p. So let's copy that here real quick. Yep. So let's paste it right there. Now we'll need to make some adjustments. Let's remove this p of chords equals pause, and we'll need to call the move, collide, and render functions. Let's start with the move shape function. So move shape of, basically shape, yeah, and collide shape w and h. The same thing for the render function, render shape of shape. Alright, so now we have a function to display things. Let's define something that we would display. So let's start with a box function. So def box, and basically it will take as an argument an x for position. Let's initialize it to 10, a y for 10, and let's set a length for the joints and the thickness, as well as the color. Let's initialize it to the blue, 100, 100, and 255. So first of all, we'll need to define a points list. So it's going to be points equals to, so let's call the point function point underscore, open the brackets, so x, y, and x minus 10 for the old, and y minus 10 for old x and old y. And yeah, so we'll need a radius. Let's set it to 3, and r. So basically we need to do this like 4 times to define a box, and each time we'll change the x and y so that we get a box. Alright, so basically here x plus l, and for the old x it's x plus l minus 10. Same for the third point, x plus l and y plus l. So we'll just increment all of them. And for the last one, it's only the y that will be y plus l. Alright, now we need a joints dictionary, list. So joints equals, so basically we'll tell it that the first and second element are connected, the second and third, the third and fourth, and the fourth and first, so that it loops through all the 4 points. Now we'll return the shape of points and joints. All right. Now let's call a box function. Let's just keep the default variable values for the arguments, and we'll call the simulate shape on it of B. Let's see what it looks like. Wait, I have an error somewhere. Yeah, it seems. Well, it seems like the collide shape. Oh yeah, in the definition of the collide shape, I forgot to put the W and H. So yeah, let me just correct that real quick. All right, now it works. So as you can see, we have a box, but we don't really have a constraint. So we'll need to define another function that will constrain the lengths or the joints of the box. So let's first of all add a lengths information holder in a way to the shape structure. So it will be a list that will hold the distances between the points that we will be adding to the shape. So we'll need to define a distance function between 2 points. So distance of P1, P2, it will return basically the square root of something. So something to the power 0.5, and that something will be something squared plus something squared. That first something squared is P1 of chords of 0 minus P2 of chords of 0. So the x value for P1 minus the x value for P2, and plus the x value for the y value for P1 minus the y value for P2 squared. So yeah, it's just the normal distance function. Oops, I forgot to put 0 here. Alright, so now let's build the lengths list. So it will be distance of points of basically we'll be indexing it using the joints again. So it will be points indexed with joints of I and of 0 here, because we need the first point of the two joints, and the second point will basically be points of joints of I of 1. So we just call the first element of the joints. Okay, for I in range len of lengths. Again, you can again here do just points of j of 0 and points of j of 1 for j in joints. Let me do that here. So let's remove joints of I and just call j of 0, j of 1, and here for j in joints. So now let's add the lengths to the dictionary. We'll do create a new key, so lengths, 2 points, and lengths. Great. So now we'll need a constraint function. We'll need a way to constrain the two or all the segments. So now let's suppose you have a segment here of length normally or default L, and after moving it and colliding it has changed the length and it became D. So it has changed by a certain offset and its length became D. So now we need to change this length or the positions of the 2 points in a way that will bring them closer in this case. So let's define dx and dy as follows. So dx is the difference between the 2 points in x value, and dy is the difference in y value. So the question that we should ask ourselves now is basically what is the proportion of d in terms of the difference between d and l. So how big is the stick compared to the difference of lengths? And that will be basically the amount of by which we'll be multiplying dx and updating our stick or our segment. So this amount, it turns out that it's equal to L minus D divided by D. So it's very simple and optimal. An optimal way of doing this is by updating the x and y by technically updating the x by L minus D over D times the dx over 2, and updating the y value for the 2 points by L minus D divided by D times dy over 2. So 1 point is going to be plus the update values, and the other one we're gonna do minus the update values. So now let's implement this function. So let me write it between the move shape and collide shape functions right here. So let's do def constrain shape of shape. Yeah, and so basically what we'll be doing is we'll be looping through all the joints, and we'll be updating the positions of each point in each joint, so that it will be constrained to the length, to the initial length. That's why we needed to define a length information holder or a list in the dictionary of the shape structure. So here, we're gonna be technically loop through all the joints. So for I in range of length of the shape of joints, technically. So what do we do when we do that? So the first thing we need to do is get the length. So the length is technically shape of lengths of I, because it's a list that has multiple lengths, and every length corresponds to a joint. So shape of lengths of I, and we need a distance, the distance between the 2 points. So that's the current distance, or the deformed distance. So let's call it d, or dist equals the distance. We're gonna call the distance function, and the 2 points that are in question here will be called using the joints here again. So shape of points of joint, or shape of joints of I and of 0. So that's so that it gives us the first point of 0, and the second point will be just calling the first element of the shape joints of I list. So let's copy that, and it's gonna be here. Let's just modify that 0 and make it 1. Next, we'll need to define another variable that will hold basically the information about the difference dx and the difference dy. So we need the diff x and diff y variables. So it's just the difference between the x value and y value for these 2 points. So we're going to call here, we're going to call we need chords of 0 and we need chords of 1. Let's just copy that and paste it again. Diff y, so it's you're gonna change 0 for 1, and that's basically it. Oh, we needed to call the chords first before the index. Same thing for all of these points. So before the index, we're gonna call chords here, and oops, before the 1, and last but not least before. Wait, yeah, that's it. Before the 1 and before the 0. So after we've done that, well, now we got all we need. Now we need to calculate or to compute the update x and update y. But before that, I guess, let's just see. So it's gonna be 1/2 times the diff x, and we're gonna multiply it by L minus d distance. So L minus dist divided by dist. So let's define a difference variable. It's going to be L minus dist, and in the update x, it will be the diff divided by dist. So that's it. And the same for the update y. It's going to be 0.5 times the diff y times the diff divided by the dist. Yeah. Now we need to update our points. So we're gonna call the shape of points, of shape of joints, of I of 0, of chords of 0. We'll be incrementing it by the update x. So let's do that. Shape of points of basically shape. So it's the same one here. Let's just copy that and paste it. Here we go. Yep. Now chords of 0 plus equals update x, and the same thing, just 1 here in this index, plus equals update y. So you're gonna notice that the point that you will be incrementing by the positive value is the one from which you subtracted in the diff x and diff y. So let's update the second point. It's just going to be the same thing. Let's paste it right here. So we're just going to change the y value, and the indexes are going to be ones, and we'll have minus instead of plus. So that's about it, really. Now we need to call the constraint function after the move shape function. So constraint shape of shape, and that technically will do it. Alright, let's see what that looks like. So now you can see that we had a box for a couple seconds. That's technically because we need to add a third joint to the joints list in order to make it more stable. So let's try that out now. We added a joint between the third and the fourth and the second point. That's not stable as well. I wonder why, but let's just add a third, another or sixth joint here. Or is it a seventh? So it's going to be between the index 2 and the index 0. So it's the leftmost, topmost point and the right bottommost point. So that's technically it. That did it. So I hope you enjoyed and that this was really helpful. So in the next part, part 4, I'll be doing some chains, ropes, and maybe fabric. Stay tuned for that, and thank you for watching. Have a good day.